Okay, Tejas.
Yes, sir. Thank you, sir.
Thank you. Sir, நீங்க start பண்ணலாம் sir.
Good evening to all. So today's lecture program is HVAC and refrigeration system. We'll focus only for fundamentals of what is HVAC and refrigeration system. So HVAC means heating, ventilation, and air conditioning.
Sound வரலைங்க sir.
ஆமா ஸ்லைடு இல்ல ஸ்லைடு மூவ் ஆகல. ஓகே
மூவ் ஆகுதுங்க சார்.
ஓகே ஆமா ஆமா.
நீங்க இல்லைன்னா கீபோர்டு கூட யூஸ் பண்ணிக்கலாம் சார்.
ஓகே ஓகே ஓகே. So the heating, ventilation and air conditioning and refrigeration system transfers the heat energy from or to products or building environment. It is nothing but a heat transfer. Energy in the form of electricity or heat is used to power mechanical equipment designed to transfer heat from a colder, low energy level to a warmer, high energy level. See, the term is commonly for heating and cooling. The refrigeration deals with the transfer of heat from a low temperature level at the heat source to a high temperature level at the heat sink by using a low boiling refrigerant. The refrigeration system. Small capacity modular units of direct expansion type similar to domestic refrigerators, small capacity refrigeration units, centralized chill water plants with chill water as a secondary coolant for temperature range over 5 degrees C. Typically, they can also be used for ice bank formation. Brine plants, which use brines as a low temperature for typically sub-zero temperature applications, which come as a modular unit capacities as well as large centralized plant capacities. The plant capacities up to 50 TR are usually considered as a small capacity. 50 to 250 TR as medium capacity and over 250 TR as a large capacity units. So here TR means ton of refrigeration. So in HVAC system, we will called capacity as a TR, ton of refrigeration. So for example, for window AC, we called 1 ton, 2 ton, 1.5 ton. So in the case of split AC also, 1.5 ton, 2 ton, 3 ton, and so on. So commercially we will call ton, but it is actual name is TR, ton of refrigeration. In the case of domestic refrigerator also, yeah, refrigerator is also working as refrigeration cycle. In the refrigeration, there is two types. One is vapor compression system, another one is a vapor absorption system. So today we will go to see only the vapor compression system. When the refrigeration system or equipment, there are various types. Refrigerator called fridges, refrigerator in domestic purpose. Then window air conditioners, split air conditioners. Then direct expansion system for small office units. Then chill water plant for the larger buildings. In case of multi-storage building, 5-storage building, 10-storage building. Normally we use for corporate office buildings, then hospital buildings, and star hotel buildings, shopping malls, then IT buildings. So these are the application for the HVAC system. So depends upon the area, built up area, the capacity vary. For larger built up area, the capacity of the HVAC system is larger. So this is the Vapour compression system, refrigeration system. So in refrigeration Vapour compression system, there is a 4 equipment: compressor, condenser, expansion system, expansion valve, and evaporator. This is the simple refrigeration cycle. It is further classified as air-cooled system and water-cooled system. For smaller capacity units, we use air-cooled system. That air-cooled means air-cooled condenser. The water-cooled system means water-cooled condenser. Okay. So in the refrigeration system, if we start from compressor, the refrigerant gas will compressed as a high pressure and high temperature vapor. Then it goes to condenser. In the condenser, it cools to low temperature and high pressure. Then it goes to the expansion valve, where the high pressure gas expand the low pressure, then low temperature, and it goes to the evaporator. The evaporator is the otherwise called cooling coil. So depends upon the equipment, it varies. For refrigerators, called freezer. Okay. Then again, whatever the load, product load is there, it will absorb. So absorb the heat, then again it becomes low pressure vapor, and again it goes to the compressor. This cycle is repeated. So in the diagram, it shows the AC unit, window AC unit. That's why we have the condenser fan and evaporator fan. So this is the evaporator fan, where you will get the cooling effect. Is it okay? This is the basic refrigeration system. So compressor, hermetic compressor is used for the, since it is smaller unit, so we are using the hermetically sealed compressors. That means everything is closed. We cannot see the compressor and motor. The compressor name is reciprocating compressor, or nowadays scroll compressor are in use. So we could see the color coding. The refrigerant, the phase condition of the refrigerant, whether it is high pressure or low pressure. Okay, that's low temperature. The color coding shows the condition of the refrigerant. So low pressure gas, high pressure gas, low pressure liquid, high pressure liquid. The Vapour compression refrigeration system using R22. So we could see the block diagram. What is the temperature? What is the pressure? The various stages, equipment. See, we see the compressor, the hot gas 43.3 degree C and 1585 kilopascal. It goes to the condenser where it becomes a liquid. Then again, hot liquid goes to the expansion valve. It becomes low temperature, low pressure liquid. It goes to the again evaporator. It cools the product or the air. So atmospheric air becomes the cold air. So 23.9 degree C is come down to 12.8 degrees. So it is divided into two parts, high side and low side. Compressor and condenser up to expansion valve is called high side because it is high pressure and high temperature. Then below the after expansion valve and evaporator, it's called low side since it is low pressure and low temperature. So again, a little bit more this compressor, condenser, and expansion valve, evaporator. So we could see the phases, various phases of refrigerant. So other side you can see the pressure enthalpy chart, where you can see the pressure and enthalpy. So 1 to 2 is the compression. 2 to 4 is the condensation. Then 4 to 5 is the expansion of refrigerant. Then 5 to 1 is the evaporation. See, it consists of 4 phases. Coefficient of performance. The COP is the refrigeration effect, that is kilowatt divided by the work input kilowatt. So very, very important for the refrigeration cycle in vapor compression system. What is the COP? So based on the COP only, we will get the refrigerating output. So in the graph 1 to 2 compression, that is isentropic compression. Then condensation is the isobaric condensation. The expansion is the isotopic expansion. Then evaporator is the isobaric evaporation. Vapour compression system. Heat flows naturally from a hot to a colder body. In refrigeration system, the opposite must be occur. That is, heat flows from a cold to hotter body. This is achieved by using a substance called refrigerant, which absorbs heat and hence boils or evaporates at a low pressure to form a gas. The gas is then compressed to a higher pressure, higher temperature, such that it transfers the heat it has gained to ambient air or water and turns back. It's called condensation into the liquid. In this way, heat is absorbed or removed from a low temperature source and transferred to a higher temperature source. See, it is working based on the thermodynamic principle. So you could see the simple compression cycle, Vapour compression cycle. So it starts from the compressor. The compressor is coupled with a prime mover. So normally it is a induction motor or any engine, gas engine or diesel engine. It goes to the condenser where it cools by the water. This system is called water cooled system. Then the low temperature liquid, high pressure, low temperature, high pressure liquid is again exposed to the expansion valve that expand to a low temperature, low pressure, and it goes to the evaporator. Since it is chill water system, the evaporator is called chiller. Then again this vapor, low temperature vapor goes to the compressor. That cycle is repeats. In this water cooled system, we require cooling tower, then condensed water pump, then here also chill water pump, the chill waters, secondary pump, and a primary pump. So for higher, larger building, so we required primary pump as well as the secondary pump for pumping the water to the AHU units through pipelines. So again, this chart, figure chart. So we could see the various components, equipment, compressor, condenser. We could see specifically to the cycle. So this region is called liquid region. This region is called vapor, superheat vapor region, this side, compressor side. So this is already discussed. What is the function of all four equipments: compressor, condenser, expansion valve, and evaporator. So we could see the useful capacity of the evaporator, cooling capacity. We could see this is the useful capacity. There is the, then again this is the heat rejected from the condenser. In that pH start 1 to 2 low pressure liquid refrigerant in the evaporator absorbs heat from its surroundings, usually air, water, or some other process liquids, brine solutions. During this process, it changes its state from a liquid to gas, and at the evaporator exit, slightly superheated. Then 2 to 3. This refers to the chart, pH chart. The superheated vapor enters the compressor where its pressure is raised. There will be also a big increase in temperature because a proportion of the energy input into the compression process is transferred to the refrigerant. Then 3 to 4, the high pressure superheated gas passes from the compressor into the condenser. The initial part of the cooling process, that is 3 to 3A, desuperheats the gas before it's then turned back into the liquid. That is 3A to 3B. The cooling for this process is usually achieved by using air or water. A further reduction in temperature happens in the pipe work and liquid receiver, that is 3B to 4, so that the refrigerant liquid is subcooled as it enters the expansion device. 4 to 1. The high pressure subcooled liquid passes through the expansion device, which both reduces its pressure and controls the flow into the evaporator. It can be seen that the condenser has to be capable of rejecting the combined heat inputs of evaporator and the compressor. That is 1 to 2 and 2 to 3 has to be the same as 3 to 4. There is no height loss or gain through the expansion device. So it will simply expand the liquid. The output will get the output low pressure and low temperature liquid. Then common used refrigerant and properties. R11 or Freon 11 is called. Property: non-toxic, non-flammable, and non-corrosive. It is used for small office building and factories for the refrigeration system. R12 or Freon 12. Properties: non-toxic, non-flammable, non-explosive, high COP, and most suitable refrigerant. It is used for its domestic vapor compression refrigeration system. R12. Properties are non-toxic, non-flammable, non-explosive, require less compressor displacement. It is used in commercial and industrial low temperature applications and air conditioning. See, these are the types of refrigerant used for the vapor compression refrigeration. So, alternative refrigerant for vapor compression system. The Montreal Protocol of 1987 and the subsequent Copenhagen Agreement of 1992 mandate a reduction in the production of ozone depleting fluorinated fluorocarbon (CFC) refrigerants in a phased manner, with an eventual stop to all the production by the year 1996. In response, the refrigeration industry has developed two alternative refrigerants, one based on hydrochlorofluorocarbon (HCFC) and another based on hydrofluorocarbon (HFC). The HCFC have a 2 to 10% ozone depletion potential as compared to CFCs, and also they have an atmospheric lifetime between 2 to 25 years as compared to 100 or more years for CFCs. However, even SCFC are mandated to phased out by 2005, and only the chlorine-free zero zone depletion HFCs would be acceptable. Until now, only one HFC-based refrigerant, HFC 134A, has been developed. HCFC are comparatively simpler to produce, and the three refrigerants R22, R123, and 124 have been developed. The use of HFC and SCFC results in slightly lower efficiency as compared to the CFCs, but this may change with increasing effort being made to replace the CFCs. CO2. See, we know that some refrigerants is Freon 12, Freon 22, and all having the potential of depleting the ozone depletion potential. So we have to phase out. So already I think 2-3 refrigerants are phased out. So alternatively, HFC 134 is normally used for the refrigerants for AC plants. Again, CFCs are on the way out. So 80% of the today's existing chillers are centrifugal chillers that use R11 as refrigerant. The newer non-CFC alternative to R11 is HCFC 123. Some centrifugal chillers use R12. Its non-CFC alternative is HFC 134A. Unitary AC units typically use R22, which will be phased out in the future. So these are the tabular column. What are the refrigerants? What is the phased out dates? So already R11, R12, R22 are already phased out. So HCFC 123 target is 2030. So production of this refrigerant is stopped. Conceptual view of a chilled water air conditioning system. See, cooling coil, evaporator, condenser, cooling towers. So since it is the water cooled system, so we could see the supply air fan, chilled water pump, compressor, condenser pump, then cooling tower fan. So these are the various loop cycle. So in the figure, thermal energy moves from left to right as it is extracted from the space and expelled in the outdoors through 5 loops of heat transfers. Indoor air loop. In the leftmost loop, indoor air is driven by the supply air fan through a cooling coil, where it transfers its heat to the chilled water. The cooled air then cools the building space. So it is circulated through the ducting system to the various space in the floor. Then chilled water loop, driven by the chilled water pump, water returns from the cooling coil to the chillers evaporated to be recooled. Refrigerant loop, using a phase change refrigerant, the chillers compressor pumps heat from the chilled water to the condenser water. Condenser water loop. Water absorbs heat from the chillers, condensers, and the condenser water pump sends the cooling tower. Cooling tower loop. The cooling tower's fan drives the air across an open flow of the hot condensed water, transferring the heat to the outdoors. So this is the various cycles: air cycle, chill water cycle, condensed water cycle, then cooling tower. Psychrometry. What is meant by psychrometry? Psychrometrics is the science of mass air properties and the process which is used to illustrate and analyze air conditioning cycles. It translates the knowledge of heating or cooling load into a volume flow rate for the air to be circulated into the duct system. So this is the very, very important chart for the HVAC engineers for designing the air conditioning system for the particular application. Air conditioning process includes simple heating, raising the temperature, simple cooling, lowering the temperature, humidifying, adding moisture, and dehumidifying, removing the moisture. So that is the depends upon the country. See, in Indian countries, so we are using the cooling. Then American countries, European countries, they are using the heating. That is why we are using the both terms. Psychrometric chart. The properties of atmospheric air at the specified total pressure are presented in the form of easily readable chart called psychrometric chart. So the dry bulb temperature are shown on the horizontal axis. The specific humidity is shown in the vertical axis. A wet bulb and the saturation curve, enthalpy, dew point, absolute humidity axis, relative humidity axis, dry bulb axis, specific volume. So psychrometric charts showing these so many parameters. So design HVAC design engineers, it is very useful for the design engineers to design the AC system. Then type of compressors and applications. For industrial use, open type system, compressor and motors are separate units are normally used. For domestic purpose, we are using the hermetic system. See, though hermetic system, motor and compressors in a sealed unit also find service in some low capacity applications. Hermetic systems are used in the refrigerators, air conditioners, and other low capacity applications. Industrial applications largely employ reciprocating compressors, centrifugal compressors, and more recently screw compressors and scroll compressors. Water-cooled systems are more efficient than the air-cooled alternatives because the temperature produced by the refrigerant condensation are lower with water than the air. Centrifugal compressors. Centrifugal compressors are the most efficient type when they are operating near full load. Their efficiency advantage is greatest in larger sizes, and they offer considerable economy of scale. So they dominate the market for larger chillers. They are able to use a wide range of refrigerant efficiently. So they will probably continue to be the dominant type in large sizes. Centrifugal compressors have a single major moving part, an impeller that compresses the refrigerant gas by centrifugal force. The gas is given a kinetic energy as it flows through the impeller. This kinetic energy is not useful in itself, so it must be converted to the pressure energy. This is done by allowing the gas to slow down smoothly in a stationary diffuser surrounding the impeller. To minimize efficiency loss at reduced loads, centrifugal compressors typically throttle output with inlet guide vans located at the inlet to the impellers. This method is efficient down to about 50% load, but the efficiency of this method decreases rapidly below 50% of load. Older centrifugal machines are not able to reduce the load much below 50%. This is because of the surge in the impeller. As the flow through the impeller is choked off, the gas does not acquire enough energy to overcome the discharge pressure. Flow drops abruptly at this point, and isolation begins as the gas filter back and forth in the impeller. Efficiency drops abruptly, and the resulting vibration can damage the machine. Many older centrifugal machines deal with the low loads by creating a false load on the system, such as by using hot gas bypass. This wastes the portion of the cooling output that is not required. Another approach is to use variable speed drives in combination with the inlet guide vans. This may allow the compressor to throttle down to about 20% of full load or less without false loading. Changing the impeller speed causes a departure from optimum performance. So efficiency still declines badly at low loads. A compressor that uses a variable speed drive reduces its output in the range between full load and approximately half load by slowing the impeller speed. And lower loads, the impeller cannot be slowed further because the discharge pressure would become too low to condense the refrigerant. Below the minimum load provided by the variable speed drive, inlet guide vans are used to provide the further capacity reduction. So that's why mostly used in chiller plants, centrifugal compressors are used for the chiller plants. Reciprocating compressors. The maximum efficiency of reciprocating compressors is lower than that of centrifugal and screw compressors. So efficiency is reduced by clearance volume. The compressed gas volume that is left at the top of the piston stroke. Throttling losses at the intake and discharge valves. Abrupt changes in gas flow and friction. Lower efficiency also results from the smaller size of reciprocating units because motor losses and friction account for a larger fraction of energy input in smaller system. Reciprocating compressors suffers less efficiency loss at partial loads than other types, and they may actually have a higher absolute efficiency at low loads than the other types. Smaller reciprocating compressors control out by the turning on and off. This eliminates all part load losses except for a short period of inefficient operation when the machine starts. Larger multi-cylinder reciprocating compressors commonly reduce output by disabling, that is unloading, individual cylinders. When the load falls to the point that even one cylinder provides too much capacity, the machine turns off. Several methods of cylinder unloading are used and they differ in efficiency. The most common is holding open the intake valves of the unloaded cylinders. This eliminates most of the work of compression, but a small amount of power is still wasted in pumping refrigerant gas to and fro through the unloaded cylinders. Another method is blocking gas flow to the unloaded cylinders, which is called suction cutoff. Variable speed drives can be used with reciprocating compressors, eliminating the complications of cylinder unloading. This method is gaining popularity with the drastic reduction in costs of variable speed drives. Screw compressors. Screw compressors, sometimes called helical rotary compressors, compress refrigerant by trapping it in the threads of a rotating screw-shaped rotor. Screw compressors have increasingly taken over from reciprocating compressors of medium size and large sizes, and they have even entered the size domain of centrifugal machines. Screw compressors are applicable to refrigerants that have higher condensing pressures such as HCFC22 and ammonia. They are especially compact. A variety of methods are used to control the output of screw compressors. There are major efficiency differences among the different methods. The most common is a slide valve that forms a portion of housing that surrounds the screws. Using a variable speed drives is another method of capacity control. It is limited to oil injected compressors because slowing the speed of the dry compressor would allow excessive internal leakages. There are other methods of reducing capacity, such as section throttling, that are inherently less efficient than the previous two. That is reciprocating compressor and centrifugal compressors. So nowadays, in chiller plant, screw compressors are used. Scroll compressors. The scroll compressor is an old invention that has finally come out the market. The gas is compressed between two scroll-shaped vanes. One of the van is fixed, and other moves within it. The moving vans does not rotate, but it is center revolves with respect to the center of the fixed van. This motion squeezes the refrigerant gas along a spiral path from the outside of the vans towards the center, where discharge force is located. The compressor has only two moving parts, moving vans and a shaft with an off-center crank to drive the moving van. Scroll compressors have only recently become practical because close machining tolerance are needed to prevent leakage between the vans and the casing. Selection of suitable refrigeration system. A clear understanding of the cooling load to be met is the first and most important part of the designing. Selecting the components of a refrigeration system. Important factor to be considered in quantifying the load or the actual cooling need. Heat, cool, leaks, and internal heat sources from all heat generating equipment. So in the case of building, there is a IT equipment and lighting, then air conditioning equipment. Consideration should also be given to the process changes and or changes in the ambient conditions that might affect the load in the future. Reducing the load, example, through better insulation, maintaining as a high cooling temperature, as practical, etc. Is the first step towards minimizing electrical power required to meet the refrigeration needs with a quantitative understanding of the required temperatures and the maximum, minimum, and average expected cooling demands. Selection of appropriate refrigeration system, that is single stage, multi-stage, economized compression, compound, cascade operation, direct cooling, secondary coolants, and equipment, type of refrigerant, compressor, evaporator, condenser, etc. can be undertaken. See, these are all the various factors while choosing the refrigeration system or air conditioning plant to the particular application, whether it is building or industrial applications. So coefficient of performance, it is the ratio of cooling capacity in kilowatt to the total power input in kilowatt at any given set of rating conditions. That is, COP is the refrigeration effect in kilowatt divided by the work input in kilowatt. The theoretical coefficient of performance, that is Carnot cycle. COP Carnot, a standard measure of refrigeration efficiency of an refrigeration system, depends on two key system temperature, evaporator temperatures, that is TE, and condenser temperature, TC. COP Carnot equal to TE divided by the TC minus TE. This expression also indicates that the higher COP Carnot is achieved with the higher evaporator temperature and lower condenser temperature. Ton of refrigeration, TR. It is defined as a rate of heat transfer that results in the freezing of 1 ton of pure ice at 0 degree C in 24 hours. 1 TR refrigeration equal to 3024 kilocalories per hour, heat rejected. Also, it is equal to 12,000 BTU per hour, also equal to 3.5 kilowatt. The refrigeration TR is assessed as TR equal to Q into CP into TI minus TO divided by 3024. So here Q is the mass flow rate of coolant in kg per hour. CP is the coolant specific heat in kilocalorie per kg per centigrade. TI is the inlet temperature of the coolant to the evaporator. So nothing but a chiller in degree of C centigrade. TO is the outlet temperature of the coolant from evaporator in centigrade. Note, the above TR is also called as a chiller tonnage. So while doing the problem, so we have to use the formula. What is it? To find out the capacity of the chiller or capacity of the AC equipment. So this is the view of the pictorial view for the Vapour compressors refrigerator. So we could see the various evaporator, condenser. Okay. And this is the, again, refrigerator. So we could see the various parts and various temperature difference. Low pressure, low temperature, liquid vapor mixer, then condenser. Okay. So domestic vapor compression refrigerator, it consists of an evaporator installed in the freezing compartment of the refrigerator. One end of the evaporator connected to the suction side of the compressor and other end connected to the condenser through throttle valve. Normally, condenser installed at the backside of refrigerators. The delivery side compressor is connected to the condenser. Available in capacity of 65 liters, 100 liters, 165 liters, 275 liters, and so on. with the star brand. 3-star, 4-star, 5-star. So if the star increases, more energy conservation, more efficiency, energy efficiency refrigerator. See there, power consumption, energy consumption is less. So this is the view of the window air conditioners. We could see the compressors, hermetically sealed compressors, fans, blowers. So it is partly outside and partly inside the room. So evaporator side is inside towards the inside, then condenser coil is outside. Cooling coils, blower, expansion valve. So here expansion valve is capillary tube or electrical expansion valve. How it works? The hot air coming from the room is flowing on the evaporator, that is cooling coil. The cooling coil absorbs heat from the room air. The moisture of air gets removed on the cooling coil surface by process of condensation of air. Thus, the air is cooled and dehumidified to meet the requirement comfort air conditioning in the room. The filter cleaning the air coming from the room before pass through the cooling coil. The tray is provided below the cooling coil, that is evaporator, to collect the moisture which condenses from the recirculation of air. The flow of hot air from room and cooled air to the room is taking place by the evaporator blower. The refrigerating unit provides cooling effect at the evaporator. The condenser fan circulates the air on the outside of condenser tubes. The refrigerant in the condenser rejects the heat to the outside the atmospheric air. Necessary fresh air is allowed to mix with the recirculated room air to meet the ventilation requirement. So again, this is another type of split air conditioners. All are the same principle only, Vapour compression system. So here split unit, there is a separate evaporator is installed inside the room. Then condenser coil and compressor is installed outside the room. So otherwise, working principle is the same one. See, calculating the operating load of a chiller plant. So these working problems. So I think time is already 10 o'clock. So today we are not, I have not focused the problems. So next class I will focus the problems and Vapour absorption system. Sir?
Sir, close பண்றீங்களா இதோட?
Yes, sir.
Okay, sir.
So next class we will see the problems, sir. Problems and
Okay,
Vapour absorption system.
Okay, sir, please.
Okay, sir.
Thank you, sir. Thank you, please.
Because the time is, I think, 1 hour over 10 o'clock.
Yes, sir.
Okay, sir. Thank you, sir.
Sir, even if it is possible tomorrow also, you can complete it, sir.
Tomorrow, sir?
Yes, sir.
Okay, no problem, sir. Tomorrow I will
Please,
do.
sir. Please, sir.
Tomorrow I will complete
you,
Vapour absorption system and this problems. Some
Problems,
problems.
yes, sir. Yes, please, please. Thank
Okay,
you,
sir.
sir.
Thank you, sir.
Thank you so much. Thank you so much.
Balaguran, sir.
சார் சூப்பருங்க சார்.
Okay,
Hello.
thank you.
சூப்பருங்க சார். நாளைக்கும் கண்டினியூ ஆகுதுங்களா சார்?
ஆமா சார், மீதி முடிச்சிடறேன். பேப்பர் அப்சர்வேஷன் சிஸ்டம் இருக்கு, பிளஸ் கொஞ்சம் ப்ராப்ளம்ஸ் கொஞ்சம் போடும்.
வெரி கிரேட் சார். பிபிடி எக்ஸலண்டா இருந்துச்சுங்க சார். உங்களோட குரல் வளத்தோட சேர்க்கும் போது இன்னும் எக்ஸலண்டா ஆயிடுச்சு. இதை யூடியூப்ல கேட்கிறப்போ யார் வேணாலும் ஃபாலோ பண்றதுக்கு அந்த ஸ்லோ அண்ட் ஸ்டெடி வாய்ஸ் நல்லா இருந்துச்சுங்க சார். மகிழ்ச்சியா இருந்தது.
ஓகே, தேங்க்யூ. அவங்க பார்ட்டிசிபென்ட்ஸ் என்ன சொல்றாங்க? அவங்க ஏதாவது அப்சர்வேஷன்ஸ், ஏதாவது சேஞ்சஸ், ஏதாவது கிளாரிபிகேஷன்ஸ்?
எல்லாருக்கும் புரிஞ்சிருக்கும் சார் நிறைய. அதனால எல்லாரும் போய் படிக்கிறதுக்கு போயிருப்பாங்க இப்போதைக்கு.
ஆக்சுவலா இதுல 50% வந்து ஜெனரலைஸ்டு, அதாவது ஹெச்விஏசினா என்ன.
ஆமா, அதுதான் சார்.
ஸோ நெக்ஸ்ட் கிளாஸ்ல கொஞ்சம் அந்த ப்ராப்ளம்ஸ் அந்த எப்படி
பண்ணிடலாம் சார். அவசியம் சார்.
ஓகே, ஓகே, தேங்க்யூ, தேங்க்யூ, தேங்க்யூ. குட் நைட்.
குட் நைட் சார். குட் நைட்.
இப்போ ஆயிடுச்சு.